Hey everyone, hope you are doing well and welcome back to another video here on the channel. In this week's video, we're going to be talking about 5 reasons you should choose to use a sensored brushless motor for your radio control car. In the comment section below, let me know if you prefer to use a sensored motor or a sensorless motor and why exactly you choose that specific type. Let's continue from there and talk about the first item on our list of 5. The first item is improved startup performance from a sensored brushless motor. For those that don't know, sensors that exist on a brushless motor are there so that the ESC, the electronic speed control, knows where the rotor is in relative to its position to the rest of the windings that the ESC is going to send power to. If the ESC doesn't know, it has to figure it out. What sensors do is eliminate all of this guesswork, guess and check work that the ESC otherwise would have to go through. And as a result, we get a bunch of advantages that we're going to talk about here, including the first one that we're discussing right now, which is improved startup performance. Every time that you have to start that motor up, if you have a sensored motor, this is going to be flawless. We won't get that sort of cogging as it's known in the RC community where there's hesitation upon startup. And that hesitation can be quite significant all the way to the point where it is very brutal for the radio control vehicle to go through that because of the spikes in current and anything associated with that kind of power demand when you're trying to get the motor spinning up. Improved startup performance is probably going to be the #1 item and reason why you'd want to make the transition from a sensorless motor to a sensored brushless motor. #2 on our list is going to be slow speed performance. A sensored motor is going to give you that slow speed performance because it's unaffected by the speed that the motor is actually rotating at. It performs very well at 0 RPM, but all the way up to its maximum amount of RPM that setup is going to allow it to achieve. Because of this, things like rock crawling that needs that extreme slow speed when you are moving your way across a rock from rock to rock, you need that extreme good performance for that type of slow speed. And it's going to tie into the next item that we're talking about here, which deals with #3, being precise and smooth. When you're moving at a very slow speed and you come to a rest, meaning 0 speed, and then you want to move again, you want to make sure that you're doing this very smoothly. You don't want to be jumping over the rocks because that can get the vehicle unbalanced for this type of performance. And also, you want to make sure that you're doing this with a good amount of control, where you know that if you get the vehicle moving, you're going to be able to stop it in time in order to get yourself lined up for that next obstacle. Anytime that you need this sort of low speed type of performance where you also require smooth control and good control, precise control, this is where you want to be using a sensored brushless motor. #4 on our list is going to talk about torque. Now, a sensored motor is going to achieve a greater amount of torque than a sensorless motor. But the only thing that we need to know is at what RPM. And a sensored motor is going to be able to do that a lot better than a sensorless motor at 0 RPM. 0 RPM is where the motor has completely stopped, and there's multiple different scenarios that we can imagine where we would need this good amount of torque. For example, if you are trying to move your car across a rock and you have to build up a lot of torque in order to get that car up over it, this is where a sensored brushless motor is going to help you out. Another instance is where you are pulling a lot of weight with a radio controlled car. At 0 RPM, that car might be significantly loaded up and resisting motion, and you're going to need a lot of torque to get that car moving and pull and drag that load behind the vehicle. This is where a sensored motor is going to help you out a lot. Or what I've seen videos online where guys are putting their radio controlled car, hooking it up to a wagon, throwing their kids in that wagon, and then towing that along. This is where a sensored motor is going to make that a lot easier, a lot smoother for you. The torque that you get at that 0 RPM mark is much more significant than a sensorless motor would be able to provide. Now, the last item on our list here for today might actually and could be arguably the most important on our list, and that is a sensored motor could offer you more fun than you would get from a sensorless motor. And the big reason is because it kind of opens up up the ability for you to enjoy your vehicle in more ways than you could with a sensorless motor. Being able to operate very smoothly and precisely at low speed allows you to do some more significant off-road type adventures, as well as, experiment with how much your vehicle can pull in tow and all kinds of other things that you could do with your vehicle as it comes to your imagination. If I were to break down my complete lineup of radio controlled cars, the majority of my RC cars are powered by brushless sensored motors. And that is largely because of the advantages that we talked about in this video here today. However, only one of them is a rock crawler, or even could be remotely classified into that rock crawler type of classification. A couple of them are high performance, high speed radio control cars. And I choose to put a sensored motor in them because it allows us to get that smooth, controlled delivery of power right from 0 RPM. I know that when you have a really high gear ratio, it's sometimes difficult to get that car to move off the line. And when it is moving off the line, it draws a significant amount of power through the entire power system, which can be quite harsh on many of the components, especially the ESC, as it delivers that power to the motor. The easy way to avoid all of that is to simply just drop a sensored motor into the application and all of that goes away. That's how easy it is. Now, that's not to say that operating a sensored motor has no disadvantages. There are certainly disadvantages associated with a sensored motor. If you want to learn more about what applications and why it would be best for you to run a sensorless motor, there's a video that I will link in the description below. Until next time, guys, this one here, we're done. Hope you enjoyed it. Like the video if you do, and don't forget to hit that sub button so I can see you guys in the next video. Thanks a lot for watching. See you in that next one.